Hey Joshua, so this is a really simple way to do the calculations that you need to do. So right now I'm on that social science statistics variance calculator that I gave you a link to in this lab. What you can do here is plug in the 10 numbers that you recorded from your plots. So I'm just going to make up some numbers here and I'm pressing enter to move between the rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10 numbers in here, and I'm just going to hit calculate. And this is going to give me almost all the information that I need. So this is the mean, and that's telling us the mean number of individuals per meter squared plot. We're calling this the density because it's a per meter squared calculation. So when I ask you to calculate the density of the population, all you need to do is calculate the average of the 10 numbers that you recorded. So for our data set that I made up here, the density is 3.8. It's telling us down here that the sample variance is 8.84, and that's a measure of how close or far the individual samples are from the mean. So that's a fairly high variance. So if we look over here, this is telling us the number of plots. There were 10. It's telling us the density here, 3.8 individuals per meter squared, and then it's telling us the variance. So let's see, the last thing you need to do, so I don't know if this is what you're getting stuck on, calculating the population size or uppercase N, but that is a really simple calculation too. Basically, all you need to do to calculate N is take the total area of the plot, 100, divided by 1, so just 100, times the density. So 100 times the density. So with our sample data, that would just be 380, 100 times 3.8. So that's how you calculate uppercase N, or the total population size. For the distribution, what you're going to do is you're going to take that S squared, or that variance, and divide it by the mean. So for you, that's dividing, or for the data set that we made up, that's dividing 8.84? 8.84 divided by the mean, which was 3.38. So whatever value you get, you're going to compare it to these values, and you're going to say, is that number greater than 1? Is it approximately equal to 1? Or is that number less than 1? With our sample data set, 8.8 divided by 3.8, that's going to give us a number that's greater than 1, indicating that that plant was clumped in space. So the variance was a lot higher than the mean, because we had some plots with 0, some plots with 9 individuals in that sample data set. So it's really pretty simple. Joshua, if you use that that variance calculator that I gave you a link to, that'll calculate your density for you. All you need to do is multiply that by 100 to get the total number of individuals in the 100 meter squared area. It's going to give you the variance. You'll use the variance and the mean to calculate the distribution. So that's going to be the variance divided by the mean. You're going to compare that value to 1. Is it greater than 1? Is it about 1? Or is it less than 1? To make conclusions about the distribution. Is it uniform? Is it random? Is it aggregated? Okay, I hope this helps.